we have posts, and we can loop through those. This essentially replaces a for loop. And let me just log to the console each post. And you can see in the console, now we have posts from user 9, 10, all the way back up to 1. And we can see each one of their posts. Now, this works just like a for loop, but see how much easier. We just said for each post and log the post to the console. And we didn't need to define the iterator as we start with a for loop, or we didn't need to increment that iterator. And I often do this with HTML collections when I'm selecting elements from the DOM, or node lists when I'm selecting nodes from the DOM with the query selector. And then also just in an array, if I don't need that iterator, if I don't need to say define a number and refer to that each time the loop iterates, I can just use for each on an array, and then we can carry out whatever we want to with this anonymous function inside the for each loop. Okay, let me clear the console, and then we will move on to the next higher order function. And that next higher order function is filter. Now I want to start out by defining an array, because this is going to return an array. So I'm going to call this filtered posts. I'm going to set that equal to posts.filter. And now, once again, I refer to the single post within the original array. And we're going to filter these posts. So this is going to return an array. And each time it loops through the array, it's going to return a value. So I only want to return the posts where the post user ID, as we can see we have user IDs in each one of the objects here, where the post user ID is equal to 1. And I can save that, but we're not logging it to the console yet. So I'll just need to come over here and say console.log filtered posts. There we go. And now when I log this to the console, you can see we get 10 results back. And I'll go ahead and click over here so I can open this up and expand it. And you can see our user ID is 1 in each one of these objects returned. And we have an array with 10 elements. Now we can change that in our JavaScript. We could say we just want the user ID of 5 with this filter call. And now, as I open this up, you can see the user ID is 5 in each one of these. So this is a way to filter results or filter data that we get, and this higher order function is very useful. That is way better than writing all the code that it would require manually to filter without this option being available. Okay, we can move on from filtered posts, and we'll apply the next higher order function, which is map. So I'll once again start out with a array, because this is going to return an array, and I'll say mapped posts, and I'm going to set that equal to filtered posts dot map. Once again, refer to each post inside the function, and then when we map these posts, we're going to take, say, each value of the ID, let's take it times 10. And this will return an array with the post ID. So we've got 41, 42, 43. If we take it times 10, we should get 410, 420, 430. And we should return an array with just those values. So I'll log this to the console, and we can see if I'm right. Yes, we've got an array here, our mapped posts array, that has 410, 420, 430, and we could once again change the ID that is filtering the array that we're using. And now, of course, we've got 10, 20, 30, 40, 50, and of course we could do that again and get different results. So you see how that works. We are first filtering all of the 100 posts down to, at this point, just the user ID of 3. And then we're taking those results, those 10 posts, and we're mapping that. So then we're just taking the post ID and taking it times 10 and saving those values into our mapped posts array. So at this point we have an array that has 10 separate values here. Let me change this back to 10. We'll get nice bigger numbers to work with here. So 90, 91 through 100 would have been the original post IDs, and we took it times 10, so we've got 910 through 1000. Now let's look at our final higher order function, and this is called reduce. So I'm going to once again define an array, and I'll call this reduced posts. And I'll start with the mapped posts and then reduce. Now reduce is different. We're not just going to refer to the individual value post. We're also going to use what's called an accumulator. I'll call this sum, where we're going to total the values that we have. So we have 910 through 1000, and I'm going to return the sum plus the post value. And then we'll have an array. Actually, we won't have an array. We'll just have a value, because this accumulates when we reduce, and we will log that value. So I'll put reduced, probably be more accurate if I put reduced posts value. Let me change that here too, just because I like to have descriptive names. And now you can see that total value is 9,550. So we've reduced the values within the mapped posts array. And of course, each one of these will change if we come back and just change the user ID we're working with. So let's see, if we started with the user ID 5, the total value would be 4,550. If the user ID was 1, the total value would be 550. And that is the total of all of these numbers from our mapped array totaled and then given here with the reduce higher order function. So we've used each one of these higher order functions as we've worked through this. The only one we really didn't apply that I did demonstrate is for each. But I do probably use for each more often than any of the others instead of using a for loop, because it is so easy to just use for each on an array or an HTML collection or a node list and do something to each item within that array. Today our main topic is the Fetch API, but that also requires a discussion of callbacks, promises, thenables, and async await. So we'll start with callbacks. Callbacks are just functions really that are passed to other functions as parameters. So they will call that function after they finish doing their other stuff. So a quick example of defining a function with a callback, we'd have the word function, and then let's just call this first function, and we might have a parameter or however many parameters we want. And then we could have a callback, and that callback is a function. So in the function we would do stuff with the parameters or whatever, and at the end we would call that callback function. And that allows us to call a function that in turn will call another function, and it essentially is a chain of events. Well, promises are designed to get rid of this, but let's show you the problem and the reason people wanted to get rid of this. This could be called and is also known as callback hell. I don't know if I would call it hell, but it could be a problem. And what happens and how this code looks when you use callbacks, if you're using several consecutively, say you'd have your first function and you'd pass in your parameter, and then you would have your space for the callback parameter. And here you could put in an anonymous function. And now inside that anonymous function, you would call a second function that's designed to also have a callback. So it could have a parameter, and then you'd have an anonymous function there. And then maybe you've got a third function that does the same thing, and it could have a parameter, an anonymous function there. And you can see what's happening here. And each level you go deeper, and of course there could really be things in between here, like we're doing stuff here. After a while your code can get a little hard to follow, and each consecutive function that has its own callback is another level of indents, and the code just gets a little hard to follow. And you probably see this in some legacy code before promises existed, because this was a common way of doing things, but it is also called callback hell, and promises are a way to get rid of that. So now let's look at a structure without callbacks, because we won't be using those, but at least you understand why we've moved on to promises. So with promises, and I'll put the focus here on promises, they can have 3 states. So we need to understand each state of promises. One is pending, another is fulfilled, and a third is rejected. Now, promises will deliver async code. JavaScript is usually synchronous, meaning doing one thing at a time. But a promise is kind of like, hey man, I promise I'll pay you back tomorrow if you loan me the money today. Or you go ahead and I'll catch up once I'm finished with my task over here. So a promise could be pending while some other JavaScript code goes ahead and executes. Promise, it can be working on it, in other words. So you're actually executing 2 different blocks of code at once in that regard. So let's look at a promise. I'll just define it as my promise. And there is a promise object, so we'll use that for this example. We'll say new promise, and promises can resolve or reject. And then pass this along. We see that's in an anonymous function. And in this resolve or reject, I'm just going to define, say, an error variable. Right now I'll set it to, well, let's set it to false to start out with. Then we'll say if the error is false, we're going to resolve, and in this we'll say yes, resolved the promise. And then else we'll reject. There we go. And we'll say no, rejected the promise. Okay, now that we've defined my promise, oh, I've got an unexpected token, a typo there. There we go. Okay, now that we have defined my promise, we can use my promise. And I'm going to show you an example here. You'll be tempted to do this, but it won't work. But this will let me display the state of the promise though. And then I'll show you why this won't work. We'll just go console log my promise. Now we would expect to get the resolve value here because promise is false. And if promise, well, if the error is false, this value is false. And if this is false, it's supposed to resolve, and it would return, yes, resolve the promise. But let me show you what actually happens. We get promise fulfilled, and then you see yes, resolve the promise. But this is the state of the promise. This is not actually returning the value like we would work with the value in our program. Instead, to get the value out of a promise, we need to chain. Remember how callbacks in that example were chaining, because the first function that had a callback would call the second function in its callback position, and the second function would call the third function. They were chained together. So promises can also be chained together. And with ES6, when promises first came about around 2015, I believe, we did that through chaining venables. And that's the next word up here is the focus is a venable. So let me show you an example of that before we get to async await, which async await, of course, will replace the venables that we used at first with promises. But let's look at the venables first. So here's my promise. Now, instead of logging and just trying to get that information, and of course that didn't work as you see here in the console, we saw the state, but we didn't really get the information. We need to go .then, and then let's look at the value that the promise delivers. And this is an anonymous function, and we can log the value. Now I'm going to save this and we can compare. Now you see in the console, instead of getting the state of the promise, which is fulfilled, we actually got what the resolve returns from the promise, and that is yes, resolve the promise. And then with a thenable, you can add another then and do something else. Let's call this new value. And let's look here. This of course is another anonymous function. So here we can just return value plus 1, whatever. We just modify the data. And then that will be the new value passed here, because new value is the parameter for this anonymous function. And then we'll console log new value. And you can see now it has the number 1 after the exclamation mark here, because we returned value plus 1 and it went down to the next then. And sometimes you'll see it with the then on not on the same line as the promise, or you could have it all in one line actually, because these are just chained together as we do with methods as well. So we've got the promise and it resolves, and then we return the value from the promise plus 1, then we log the new value. Now if there's an error, let's look at that. So let's change this error to true, and let's look at what happens in the console. Now the promise state is rejected, and this says uncaught in promise. We didn't really catch this error, and then we see no, rejected the promise. But we can catch an error in chain thenables. What we do at the very end is chain a catch, and this catch can also have an anonymous function, and it passes in the error object, and we just say console dot, let's go with error, and pass in that error. And now when I save this, you can see on line 27, which is where we logged the error, we caught that error. And if an error happens anywhere along the way in here, including in the promise itself, it goes through the chain, and at the very end it just logs that error. So it could skip the rest of the chain actually. Whenever it encounters that first error, it goes straight to the catch, and you've got no, rejected the promise. So that is how a promise works. You've got, I'll give you an example, of course, of pending here very soon. We've looked at the state of fulfilled, we've looked at the state of rejected, and this is a promise. Now the fetch API returns a promise on its own. We don't have to create a new promise, and I'll show you that here in just a minute. But this gives you an idea of promises, and the fetch API does return a promise. Okay, before giving you an example of a pending promise, let's look at a reason we have these promises, just like replacing the callbacks we mentioned. Another reason, and a big reason, of course, for using the fetch API is requesting data from another server or another site out there on the web. And what can happen is we can have to wait. We need to wait for that data to come back before we can work with it. So we need to tell our code, hey, wait for this and then do this after we get it. And that kind of makes sense when you look at the chain of thenables. But before we work with fetch, let me give you another example. And one way to kind of, I guess, simulate how fetch works is to use a timeout in JavaScript, and that is to delay the execution of some code. So I'm going to create a second promise here, and I'll call it my next promise. And this is going to equal a new promise, and it will also have resolve and reject as our first one did in that anonymous function. Okay, but inside this one, I'm going to use the set timeout function in JavaScript. And this is part of the window object, so you could have window.setTimeout, but of course you can omit the window. Now this is an anonymous function, and to spell that out, I'll use the keyword function and, whoops, put the operator there, and then I'm missing that. There we go. So that is a callback right there for the set timeout, and then it accepts this function. And then we can put in exactly how long we want to wait. And I'm going to tell it 3 seconds. So it'll be very obvious that, hey, there's a delay before this code executes. Now inside here, we'll just put resolve, and then we can put my next promise resolved. And so after 3 seconds, we should get that return from this promise. And now we can call both of these promises in much the same way. So let's say we're going to call my next promise first in our code, and then we'll take the value from that and we'll log the value. And then we can do the same thing. I'll just copy this with the first promise. And so we've defined a couple of promises, and then we call my next promise first, and then after that we call my promise. Let's go ahead and see what we get in the console. Oh, of course I left that as an error. Let me go ahead and change that back to no error so that doesn't happen. So we resolved the first promise, and then 3 seconds later my next promise resolved. Even though we called my next promise first, we called this into action right here, of course we saw the result from my promise first because of the 3 second delay, which here's the 3 second delay, which is a pretty big delay as far as JavaScript goes. But I just wanted to make it clear that that delay happens, and maybe we need to wait on some code coming back from another server before we can move on. And this is an example also that shows you that JavaScript really doesn't wait. It's not built into waiting. But this is an example of my next promise going, you go ahead and run the rest of the code and I'll catch up. And that's exactly what happens because we see the result from my promise before we see it from my next promise. Okay, now that we've explored promises completely and we're ready to look at an example of the third state that I haven't shown, and that is the pending state of promises. And we need to do that with the fetch API. It's an easy way to display that. So what I'm going to do is define a variable called users, and it is going to be equal to the promise that is returned from fetch. Now fetch will request data from another place on the web, for example. So in this example, I'm going to use JSON placeholder typicode.com, and we're going to request users. This is a great site to get some example API data from, and that's what fetch will work with. And in this result, we should get a pending state of the promise because I'm going to attempt to log the result of the promise right away. Of course, you don't want to do this when you're trying to actually work with the data from a promise. This would be a mistake, but it will display the state of the promise. So let's take a look, and we get a promise pending. That's because this promise has not resolved. It is still kind of working on it. It's that where I said, go ahead, you guys, I'll catch up. I've got some work to do. And so the rest of the code goes ahead, but the promise is still working on it. So we attempted to log the user's value, essentially, what would be returned from the promise, while it was still working on it. And that's why we need to wait. And we wait traditionally with thenables. We say, okay, promise, finish up, and then do this. So let's look at another example of that. And I'll take this same fetch and after the fetch, instead of just ending right there with the semicolon, I'll put then, and we get our response from the API. And once we get that response, it's not really ready to work with yet. And we could log that, I guess. but I also want to show you why it's not ready to work with. I guess I'll save this first. We'll log that response. And here you see the response. But once again, it's not ready to work with. We really want JSON. You can even see that in the name of this API, JSON placeholder. But we want JSON to work with. And this is a readable stream. So we'll look at the body we get. And we see this right here. And it says readable stream. It's not data we can work with quite yet. So what we need to do is call the JSON method of that readable stream that's available here. The body, that's actually a body mixin is how it's referred to in MDN. So what we'll do is take the response and then call the JSON method for that. And we'll return this response here. So instead of logging that, I'm going to return that. And now we'll have JSON. So then we need to go to the next den. Now we have our JSON data. I'll just call it data. And here, let's log the data we get from the API. And you can see we get 10 objects back from the API, these 10 user objects. And we can expand that. And you can see each one of these has information about the user from the API. So once we've got the data, we can work with it. But we need to remember that it's within this block of this anonymous function. We can't just suddenly take the data out into the global area here, because that's not executing the code in the same order. This is saying grab the data from the API with fetch, then turn it into JSON, and then work with it here. But outside of this, in the global space, it will go ahead and execute code below the fetch in our file before this is complete. And we could look at an example of that as well. But first, we'll go ahead and say data for each, and now I'll put, whoops, user. And let's just log each user. And this is an example of working with the data in this chain. And now we've got in our console a log of each user. We pulled that data right out of the JSON and pulled each user instead of returning 10 at once. So like I was talking about, the example of not trying to refer to this data, if we had this, let's call this users again. We can get rid of this, what we have up here. And I'll just say users equals fetch. We're going to kind of run into the same problem we had before, because if I think I'm going to get that data from users and just log the data here, or whatever is in users, we're going to run into the same problem. See, users logged first, and it's that pending promise on line 18. Then we get everything on line 14, because this has to actually go get the data and come back, and it's waiting, but it's a promise, and it says, hey, JavaScript, go ahead and execute the rest of the code while I'm doing this. And that is why line 18 is executing, and we see the promise pending before we get these results. This line does not wait on this code. And that is the main thing you kind of want to understand at first about how promises work. And fetch returns a promise. So we're working with promises. Also, this method here, the JSON method of the body mixin, returns a promise. So each one of these is returning a promise as we go through the thenables chain. So we have to consider that and say, okay, this is going to happen, and then after it happens, this will happen, and then after this happens, this will happen. But this, or anything else that we just put that's outside of this thenable chain for the promise, is not going to happen in that order. It's going to go ahead and execute and not wait on this. Now, what can happen also with data that we get in this manner, we could continue to work with it, and although it's not callback hell as we previously described, we have then and then dot then and dot then, and this can kind of get out of hand too, and you can have a huge chain of thenables, and that is also not desirable. And about, I believe, ES 2017, maybe 2018, but I think it's 2017, is when async and await came about. They're keywords, kind of syntactic sugar that hides what's going on. It's another way of telling your code, wait for this to happen before I do this. But it lets us write the code in a much cleaner manner in how we're used to writing code without chaining these thenables. So let's take a look at that. Okay, moving on from thenables to async await. So I'll put that up here as the focus. Async, if I could spell, await, there we go. I won't get rid of all of this code, but I'm going to show a couple of examples for sure. And so I'm going to start out with an object defined in the global space, and we'll have my users be the object, and then we'll have a user list. And that user list is going to equal a blank array at first, at least. And so there is our my users object in the global space. And then I want to define a function. Now, when we define a function that is going to use async await, we need to tell the function right at the beginning. So we can say async function, and then just name the function. I'll call it my cool function. And then we would have our function as we normally define it. Now, I like to use arrow functions, and so that looks just a little different than this syntax, but you could see it this way. I would have const my cool function and then equals async and then the arrow. And so the only difference you've noticed from when we've defined arrow functions in the past is adding the async keyword there, or traditionally with the function keyword, you put async before the function keyword. So those are the two different ways of doing that. Now, inside this function, I'm going to define a response variable, and that's going to be equal to what we get from fetch. And I'm going to request the same data from JSON placeholder, but I'm going to use the await keyword. And this is telling my code, wait to get these results from the fetch that requests that from the JSON placeholder API before doing what comes next. So at this point, we're going to wait for this to finish before we do the next thing. And the next thing I can define as JSON user data, and I can set that equal to await once again, because this JSON method also returns a promise. So in both of these examples, I'm awaiting a promise to resolve before I get that data. And then I can just return the JSON user data. Or if I wanted to do something with that user data at this point, like log it, I could. So I could say console.log JSON user data, and we will actually have that data at that point to log, because we are awaiting each of these promises to be fulfilled before we do the next thing within this function, and it's an async function. And then we of course need to call the function. So we would say my cool function, and we can call that. Now, I haven't done anything with the my users object yet, but I will here in just a minute. Let's go ahead and save this. And you can see we once again get the 10 users returned as JSON. Now, if we wanted to loop through those here, we could, like I did with the for each before, but that just got rid of our thenables because we're just using these keywords async and await. Now, to use the keyword await, it must be within an async function. And if we're going to call this function and do anything else with this data, it of course needs to happen in order again. And that is where we get into the next part, where we could have a second function, and that second function would also need to be async. So let's say const, and let's just call this another function. Now let's call func just so I don't use that word in there too much. Okay, and then equals async once again. So our another func is an async function, and this function can await for my cool function to complete, because it's returning essentially data that is coming from promises. That's an async function. And then we could log whatever we get there. So instead of logging that JSON user data within that function, we can go ahead and log it within this function, and we'll need to set this to data at least, so we can call it something, and we'll log that here in another func. So instead of calling this function right here, let's call another func here and see what we get. And once again, we get the same result. So these are chained together in that regard. And in this function, we call my cool function, and we await the results from this async function before we attempt to log the data that we get from it or work with it in any other way. Now, the reason I have this my users object up here is because this is where mistakes can happen. Mistakes can be made. And we'll take this same data, and let's say we're going to go ahead with this second function in this data. And instead of logging it, we're going to say my users dot user list equals data, because that's already an array that we've seen. And that should work. We would get that. But let's say, okay, we've called all of this, and we want to go ahead and do something with the user list in my users. And let's just try to log it right here. My users dot user list. Let's see what we get. We're not logging anything in these functions, so this should be the only log statement. We still get an empty array, just like we defined it here. Now let's think about why this happened. We waited for these functions to execute. Another func is waiting for my cool func to get that data, and we call another func before we attempt to log to the console. But here's the problem. We need to remember that these promises are like, hey, I'm going to do my work, but you go ahead. And there's nothing about this console log statement that is waiting for anything else. It is not within these functions. It is not going to await anything. So when this script executes, sure, these are defined, and sure, we call this function that calls the others, but this function essentially has things inside of it that are saying, hey, JavaScript, go ahead and do what you need to do, and we'll get back to you. And that is a reason that this is still empty. We need to do it within this chain. So if we wanted to go ahead and put this same log statement inside our function after we set it, set the data here, then we should probably get the result we expect because it's inside the function. We've waited for these other things to complete. Then we have set the user list equal to the data, and then we're logging the user list. And I'll go ahead and I'll leave this console log statement here as well. And let's see what we get. And as expected, we do get that array of 10 users for our user list, but it only is delivered to the console after the empty array is delivered, because we log this, and this is actually happening first, even though we called this function here. So we have to kind of be aware of this chain of events that is happening. And if we want to work with the data we're getting from an async function that is awaiting data from an API at another website, and then of course we're calling that function within another async function, we need to have our expectations lined up to where we're going to work with the data inside that function, or we're going to pass that data to another function. Say at this point where this console log is on line 21, we could pass the data to another function, and that function could then work with that data because it's only called after these things have completed. But if we just have it out here as kind of a procedural top-down code, and we're not waiting on things to happen within a function, just because we call this function another func doesn't mean this line of code is going to wait for those promises to resolve. So does it seem straightforward so far, or possibly clear as mud? So let's look at some examples to hopefully clear this up. And even if it does seem straightforward for you, some examples couldn't hurt, right? So let's take a look at examples, and we'll start out with what I would call a workflow function. And this function is going to be called, I'll just get rid of this object here, we'll call this get all user emails. And we'll make it an async function. And we're going to work with fetch inside the function. So much like we had in my cool function, which I could maybe just get rid of this part and get rid of that, I guess. We'll have the response equal to the users being fetched from JSON placeholder. And then we'll get the JSON user data from the response.json, which is also returning that promise with await. And then we'll do something else. Once we've got that user data, instead of returning it right away or anything else, we'll go ahead and define a user, let's call it email array. That'll work. We'll set that equal to the JSON user data, and then we'll use the higher order function map. And we'll just go through for every user, because that's the full user object that has all of their information. We just want to return within this higher order function the user.email. So this will give us a user email array when we're finished with that. And then we can return that or log it to the console or whatever. So let's just log it to the console, and we'll have user email array is logged to the console. I'll eliminate all of that, and of course then we need to call this function. So let's call get all user emails. And let's see what we get. We get an array full of 10 emails. Once again, this seems straightforward. We have an async function. We await the response from JSON placeholder, and once we get that, that's a promise fulfilled. We have the readable stream, and so we take that response and use the JSON method on it, and we await that promise to fulfill, and then we have the user data, and then we take that JSON user data and run the map higher order function and create a new array that just has the user emails. We just peeled that out of all that other user data. And we call the function, and it logs it to the console. And it logs it to the console within the function. Let's go ahead and comment that out. Now, what we've done in the past with traditional functions, we can't do here. We would go console log and attempt to get that information, say, returned. If we had return user email array. And this function would return that data, and we would attempt to log it right here. Let's see what happens. It's a promise pending. This console log statement is not within the function, and therefore it is not awaiting these promises to fulfill. So it is still pending, and that won't work. We can call the function after we've defined it, and within the function, these things will happen in the order we expect them to. It's an async function, and we're using the await keyword to await the data we need before we filter it or map it, create this new array. We've waited to receive that data. And so inside the function, logging to the console will work. We can return this data. However, it would be more likely passed to another function. Console log is a function. We're actually logging that right there. So let's say we had another function, and in this function, it would be, well, let's say it's doing something to the DOM. So we'll say post to web page. Then we could pass in that user email array. Wow, I can't type. User email array, and post to web page could do something with that. Well, let's define our post to web page function, and it's going to receive data as the parameter, and it is called within our async function, but it is called after we have awaited this data already. So we're not awaiting anything in this function. It doesn't need to be async because we have already waited for this data to arrive. We're calling the function after we've received the data. We've already even worked with the data with our higher order map function here. And so we can just do whatever within this function, and it's not really an async await function. It's just put into place within the get all user emails function after we have waited to receive this data. So this one does not need to be async or await. And after we define the post to web page function, we need to go ahead and call get all user emails into action again, because when we call this function, it will call the post to web page function at the bottom of its order. User email array is not defined. Oh, there we go. I need to refer to that as data. There we go. And within the post to web page, it is now logging the data to the console. Okay, let's look at another example. And this example is going to expand on fetch, because fetch can receive a second parameter. So second parameter of fetch. And that is usually, or is always, I should say, is a object, and it has some settings that can be defined inside there. So let's define this function, and we'll call it get dad joke. We'll start working with a different API. It's an async function. It's going to get a response from fetch, and this will be from the URL icanhasdadjoke.com. But let's look at the second parameter of fetch. It looks like I need to get rid of a couple of extra quotation marks. So we'll put a comma, and then we start to define our object. And in this object, we can define some properties. One is the method. Now, it will default to the get method, but also, there are other methods. A form typically uses post, for example, and we can post data with fetch as well. But in this example, I'll just show the method property and we'll leave it set to get. Then there is a headers property. This is a nested object. And in this example, we'll set accept, and this is the type of data we plan to receive in return, and that is application/JSON data. And then after that, I think we're finished with the header, and we're finished with this second parameter of fetch, which I've highlighted there as you see. MDN shows many other parameters, and I will have a link to that in the description below this video. Okay, so we've defined our fetch, and we expect to await that response. Once again, we get the response, and instead of JSON user data, this is going to be JSON joke data, and we will await the response.json as we have before. And now, instead of calling other functions or anything we were doing there, we'll go ahead and eliminate that stuff. and we'll add a console.log for the JSON joke data so we can see what that is. And let me save this, and we'll call this function get dad joke. We'll call that into action. And there you can see in the console we got a dad joke. It has a really weird ID value, and here's the joke. And then we see the status, and status is 200, which also would be response.ok. We could say if response.ok, do something, but in this regard we're just bypassing that and getting the response, turning it into JSON data, and then we log that. So if we just want to log the joke instead of the full JSON data, I guess I can leave that, we just refer to the property. So I would say JSON data.joke, and now we won't get the status, we don't get the ID, we just get the joke. And of course this is returning a random joke, so every time I save it, it's going to be a different dad joke. You can see it takes just a few milliseconds or a second to get that joke returned from the server. And there you see the best time on a clock is 6:30, hands down. Ha, dad joke. Okay, this API also can deliver data that is not JSON. So let's think about that for a second. And instead of JSON joke data, we will switch this to text plain. So we expect to get text plain. Notice I'm not changing anything else. It's actually the root URL, which is a little different. It's not a different endpoint. By defining what type of data we accept from this API, it's changing what they deliver. So if we say text plain, and then instead of JSON joke data, I'm going to turn this to text joke data, and instead of awaiting response.json, there is actually a text method as well. So we'll await the response.text, and now I'm just going to log the full text here, and there we go, and we get our joke. What has ears but cannot hear? A field of corn. Ha, another dad joke for sure. But that's an example of not really changing anything except the type of data we expect to receive, and then the API responds differently. Okay, let's switch this back to JSON or application/JSON, which is typically what we do want to receive from an API. We like to work with JSON most of the time. And we put our JSON joke data, and we're awaiting response.json. And let's go ahead and log the full object one more time and get a joke. All right, now I want to go ahead and copy this full object here. And for our next example, we're going to look at using post. And that will also use the second parameter area of fetch, as we did here with this joke API. But this will actually post something instead of requesting data. We're requesting to send new data to the API that can be recorded. The API will send us a confirmation back. So let's just call this function post data, and we're going to send in a joke object. And so I need to define this joke object. And I'm going to go ahead and remove the status because it doesn't make much sense to send the status. And that looks good. It would look better if I put it on separate lines. So we'd have that, and then there we go. There's our joke object. It has an ID already and a joke. Now we'll have post data, and it accepts a joke object parameter, which, remember, the parameter doesn't have to have the same name as whatever we've defined. Just when we call the function into action, we'll actually pass in this name. This is a placeholder when we define a function. So post data accepts a joke object. The response will be defined, and we're going to send this to a different address. I'll get that address quickly. This is going to go to a test API that does let us test posting things, and it's http:/bin.org, and the endpoint we want is /post. Now the method that we're going to use instead of get is post, and then instead of accept, we're going to tell the API what content type we are sending. So this would be content-type, and we are going to send JSON, so that's fine. And now we need to specify what we're sending in the body parameter of this. When we post, it has a body parameter. It's not sent as get does in the URL as a parameter. It's actually in a separate body parameter. And we want to send JSON, so we need to use JSON stringify, and here we'll take that joke object that is the parameter we're defining in the function, and we'll pass that in. That looks good. Now we'll get a response, and we expect to get a JSON response, so that's what I will call this, because we'll have a response that we get and we'll use the JSON method on it. And at that point we can log the JSON response that we get, and then we'll call this post data, and we'll pass in our joke object. Let's see what response we get. Here's the response we got from the http:/bin.org/post endpoint when we posted our data. So we did successfully post that information to this endpoint. Now with every API, just as we did with the dad jokes API and now this test API, you want to go read the documentation for the API and see what they expect and see how they expect the data to be formatted and what headers they accept. As you can see, that was important with that dad jokes API. Now, besides using the second parameter area of fetch and passing in this object like we have in the past two examples, you can also pass data in through the URL, and that is of course with get, because that is where the get method sends data and not in a separate body property. However, you once again, I need to I guess re-emphasize, you need to go to those websites and check out the documentation, because they'll have different endpoints and they're telling you how to specify the data in the URL so you get the results that are expected. Let's look at an example of that, and here we're going to request a joke. So I will change this once again. We don't need a joke object anymore, and I'll set this function to request joke. And in this example, we'll have two parameters. We'll put in a first name and a last name. So we've got a request joke function that accepts a first name and a last name parameter. And now we've got a response. We don't need any of this now. We're back to our basic fetch with just the URL. And in this URL, I'm going to use a template literal. I'm just going to copy and paste to save a little bit of time, but I will show you exactly what I'm talking about. In this template literal, I'm specifying the URL, and then you can see it starts to add parameters. And you can always identify that in a URL where the question mark starts, and now here's the first parameter. It's first name, and then it equals, and I'm taking that first name that we're passing into the function. And that's why I'm using a template literal with the backtick, so I can insert that parameter right into the URL. And then you see the ampersand, and that's what chains parameters together after the first one. The question mark identifies where the first parameter in the URL starts. And then the ampersand lets you chain another parameter, and there could be another ampersand and another parameter and so on. And so here's the last name, and we're also passing in the last name. So in this example, I'm actually using the Internet Chuck Norris database, and it's full of Chuck Norris jokes. But we're passing in a first name and a last name that we want to insert into the joke instead of the name Chuck Norris. So there's a response, and then we'll take that and we'll get the JSON response as we have in other examples with the JSON method here, and we await both of those, again an async function, and then let's just log the JSON response dot value. And that is also important because at first I would just have to have logged JSON response and then taken a look at the object over here in the console to see what the properties were, to know what I needed to log. Or it could be in the documentation of the API and you could find out that way. I know I want to get the value from that response. So instead of looking at the entire object, we're just going to look at the value property. And here I'm going to call request joke. And instead of Chuck Norris, let's put in Clint Eastwood. And that's mostly because I can't spell Arnold Schwarzenegger. I think I could spell Arnold, but Schwarzenegger would probably be way off. So let's try Clint Eastwood in here. Save that, and here is the joke we get. And we've got the ID, the joke, and the categories. So if we specifically wanted to just get the joke, we would need JSON response dot value dot joke. There you go. The truth will set you free unless Clint Eastwood has you, in which case, forget it, buddy. Yeah. Let's change that. Here's a name I can spell, Bruce Lee, kind of a Chuck Norris action hero as well. Scientifically speaking, it is impossible to charge Bruce Lee with obstruction of justice. This is because even Bruce Lee cannot be in two places at the same time. Some jokes are probably better than others. Now let's see what else we might do with this API, because there are other parameters we can pass. So besides the first name and the last name, we can add on to the URL another ampersand and then limit to equals, and then this expects an array of categories, and we're just going to give it the nerdy category. We just want nerdy jokes. The class object inherits from Bruce Lee. Ha, that's better. Okay, maybe let's try one more. But these are just nerdy jokes. Bruce Lee can overwrite a locked variable. Maybe not as good as the first one, but I get where they're coming from. Okay, now let's abstract all of this that we can into functions, more like we would in an actual program. So let's just say abstract into functions, and we'll start breaking some of this down. And the way we would start out is maybe we're pulling data from a form. I'll put maybe from a form on the website, something like that. So we would have a function const, I'll say get data from form. And we'll make this an arrow function. It doesn't need any parameters, but say it gets called into action based on the click event of a button, or possibly the submit event of a form, something like that. And we'll define a request object here. So const request object equals, and here we'll have first name Bruce, last name Lee, capital L, there we go. And then categories. And now we'll have our array that has our nerdy category in it. And that is our request object. And we're going to return the request object. So that would be our function that gets the data from the form based on the submit event or something like that, is when it's called into action. That's the first function. The next one, let's say const build request URL. And there we're going to pass in the request data that is needed to build that URL. And in the build URL, we're just going to return a template literal. And let's look at this template literal that we have here and think about what we could do to modify that so it works in the function. There we go. So we don't want to just return it as is, we want to change that just a little bit. So this would be request data dot first name. Notice how we didn't have to pass in a larger number of parameters. We're just passing in the object. And by doing that, we can then request each of these individual pieces of data from the object. And that keeps our parameter count down as far as making our function instead of having this long list of parameters. So once again, here we can say request data, name the parameter, and get that. And then even where we have the limit to, inside here, we can change this array. And inside the array, or inside this area, we can say request data dot categories, and it will insert the array that we already have in our object. And we're returning that, and that is the build request URL function. It's just going to return the URL based on the object we pass in. So that is another simple function as we would make in a program. And then we'll have our request joke function. And this will be just a little different now. It won't take the first name and last name. It's just going to accept a URL. And then notice this is an async function once again. Our others aren't, but at this point, this is an async function. And this makes this a lot easier because instead of await fetch with this long URL here, we're just saying await fetch URL. That's nice and short, easy to read. Then our JSON response is the same line as we've had previously. And then from here, we can get a joke array, and we can have that set equal to JSON response dot value. Well, when we think about getting an array, we expect to get more than one joke. So let's go back and look at this build request URL. We could just get one here. So maybe we just want to say joke to begin with. So I'll just say joke. And then that is the response.value. Or this would be a joke object because it's not just down to the joke yet. If it was down to the joke, we would say JSON response.value.joke. So let's go ahead and do that. And then we can just log the joke right here. And that would be good enough there. Is there anything else we want to do? Oh yeah, post joke to the page. So instead of logging it right there, actually, what we want to do is call a function that would display the joke. So I'll call that post joke to page, and we're going to pass in the joke. And now in our post joke to page function, we'll accept a joke, and here is where we will go ahead and just log to the console because we don't have a DOM set up to work with right now. Now we won't call that request joke. We have to call all of these functions into action. See, we've got our get data from form that might be called with an event listener, and then we've got the build request URL, the request joke, and the post joke to page, but they're not pulled together in any fashion yet. So we need kind of a procedural workflow function, and I'll just put that here again, procedural workflow function, that's how I look at them, that does all of these things. Now notice we do have an async function that needs to be in this procedural workflow. So when we define this function, we'll call it process joke request. This is actually the function that would be called by an event listener instead of the get data from form. Say there was a click on the submit button, or the submit value, or this, I guess just the submit event is triggered by pressing enter sometimes from a form. It would call this function into action, process joke request. And it needs to be an async function because it's going to call an async function into action. So here we'll have const request data, and we'll set that equal to our get data from form function. And then we'll const request URL, and we'll set that equal to build request URL, and of course that function needs the request data that we just defined. And then we will await request joke, and we'll pass in the request URL. And then we could just pretty much be done at that point. Or we could log finished, just so we know we're done here in this example. But this is the function, our process joke request, that would be called into action by an event in the DOM, and then all of these other things would fall into place based on that. But we've broken out all of these things into functions so they could work one at a time, and that happens in this procedural workflow function. So let's pretend that something calls all of these into action now, like a submit event, and I'll just put process joke request, and we'll call it here. Save that, and here we get our joke. Bruce Lee can write to an output stream, and then we get finished. And it looks a lot longer, but this is how we would actually approach this in a program. We would write individual functions for each of these things, and abstracting this, of course, lets us build a different request URL if we need to by getting different data. And of course, we wouldn't always assign Bruce Lee as the name. Possibly there's something else built into our program that would let us assign different names or pick different categories. And then we end up requesting the joke, and here's where we might work with the DOM to actually post the joke to the page, and instead we're just logging it to the console. And this procedural workflow function pulls it all together. And you can see that I just called the function right here instead of actually setting it up with some button in the DOM to do so. But you need to remember this function needs to be async because we're using await when we call the request joke function, and that request joke function is async, which is why we can use await with it. And it's saying, let all of this finish before we do anything else. Let's get started exploring regex today. You can see I'm at the regexr.com website, and I have pasted in some text from a classic song from Neil Young called Heart of Gold, and we're going to explore the text just a little bit with regex. First, let's look at character sets. We can put in a bracket and then specify some characters. I'll do E, an N, an L, and another bracket. And notice how it matches all of this pattern, matches all of these letters individually. Each one is a match. Even though some are side by side, they are individual matches. And likewise, we can put in a caret right in front of this character set. And now it matches everything except those three characters. And notice that even includes apostrophes and spaces in these lyrics. So you have a selective character set and then a negated character set. Then you can also specify a range within brackets. So we can say A-Z, and that is all lowercase letters. Notice it did not select any of the spaces, did not select any apostrophes, it did not select any of the capital letters. Likewise, we can select all of the capital letters, and now we didn't select any of the lowercase letters or anything else. This is a good time to point out flags as well. Notice this website, and typically when you define a regex definition, starts with a slash, you have your definition, it ends with a slash, and then there are flags, and we have the G right here, which is a global flag. If we did not have that, and you can adjust those here on the website on the far right, if we did not have that, it would just match the first one, and it would not iterate through the rest of the text. So when we use the global flag, it continues to search. It doesn't just stop after it finds one match. Other flags we might use are case insensitive. We just talked about selecting lowercase or capital case letters. And there's also a multi-line flag that we might use. Those are the three that I use the most often. Now let's look at a range of numbers. We don't really have any numbers on the page right now, so let's go ahead and add some at the bottom. Another classic rock song, 867-5309. And notice how it selects all the numbers as individual matches, but it does not select the dash in between. And then a dot. And if we use a dot, we're actually selecting everything except the new line character. If we were to select the new line character as well, it's identified with a backward slash and a lowercase n. And on some operating systems, it's a return, which is a backward slash and an R. Now, there are some other characters we can use, like a word character. So a backward slash and a W indicates all word characters. And notice how that also selected the numbers individually, but it did not select the hyphen or the spaces or the apostrophe. It would select an underscore if we add one here. And that's what a word character is in regex. All letters, all numbers, and the underscore qualify as word characters. Now we can select the opposite of that with the capital W. It's everything that's not considered a word character. And now notice we've selected all of the spaces, the apostrophes, the hyphens. Let's look at some other characters like that. We can do the same for digits, and that's a lowercase d. Now we've just selected the digits from the phone number. And likewise, if we do an uppercase D, it's everything except the digits. And so that is fairly easy to remember since it's the D and W for word. And then let's look at white space. And so if we do a backslash S, we select all of the white space. And this also includes tabs, and I believe it includes line breaks as well. So that is interesting. But if we do a capital S, just like with the others, it selects everything that is not white space. So this might lead you to think, how can I select everything? Remember, the dot was everything except a line break. The space or the white space does include line breaks. So let's create a character set here that says everything that is a space and everything that isn't a space. Whoops, let's put the bracket, and now that selects everything. That is actually the way to select everything, including line breaks with regex. Now let's look at anchors, and I'll delete the selector here. And an anchor could say what starts a line. So we use a caret, and I'll choose a capital I. And then we see we just selected the first one. What we need to do is enable the flag for multi-line, and now we're selecting every I at the beginning of a line, because now with the multi-line flag, these are considered separate selections. Before the multi-line, this only had one beginning, and that's why we only selected that I. Just like a beginning can be selected, we can also select an N. So I'll choose the letter D and then the $sign. And now we've only selected the letter D's that end a line. So we can choose the beginning and the end. You can escape characters. I'll get rid of that selector. And let's say this line had a period to end. Now remember, a period was a special character. So if we used it up here, it selected everything. So we need to escape that character if we just want to select a period. And there we have to do that backward slash. And now we've only selected the period. So that is a way to escape special characters. And you would do that with a plus symbol, an asterisk, and several other special characters that regex uses. We can create a capture group where you might extract a string from regex. And here I'll just specify a few letters like OLD. And you can see we have captured the OLD in gold as well as the word old. And we have specified that we're going to possibly extract these strings. We can also specify a non-capturing group by putting in a question mark and a colon. And now we're specifying we're selecting this, but we're not going to capture it. We can also use what's called a positive look ahead. So we'll start out with the letter G, and I only have to modify this a little bit to add the equal sign. And now I'm only selecting the letter G where it is followed by an OLD, and that's looking ahead to see what follows what we're capturing here or selecting, and that's just the letter G. Likewise, we can do a negative look ahead, and now I'm selecting all of the letter G's that are not followed by the OLD. So we have the G in give, we have the G in searching, we have the G's in getting, but not the G in gold. And so that is a negative look ahead. Now let's look at quantifiers. Quantifiers allow us to select many characters at once. And so let's specify some capital letters once again. Now that we've selected all of those, I'll go ahead and bring back the word character selector. And then notice how it only selected one letter after the capital letter. Now I'll put a plus, and it will go ahead and select almost the entire word unless there's an apostrophe, because that's not a word character. We also do not have the I's selected because this is looking for capital letters with other letters following it. There is no option to not have those other letters. So let's see how we can fix this. Let's go ahead and instead of using the plus, which means one or more characters, and that's what we had with the /W plus, I'll put that back, and that's why we selected the entire word that or keep. Let's go ahead and delete that, and now we'll put a lowercase letter selector, but we'll make it optional, and this is another quantifier. This means 0 or more, the asterisk or star, whereas the plus symbol means 1 or more. So now you can see we've selected even the individual letter I's, but then we also need the words that have an apostrophe in them. So let's go ahead and put an apostrophe, and once again put another asterisk, and that means it will select 0 or more apostrophes. And after that, there are usually some letters that follow the apostrophe. So let's go ahead and put A to Z character set again, and also make this optional. And once it's optional, we're selecting all the words we expect to that start with capitals, and whether they have apostrophes or not, they are selected. And you can see I've added a couple of extra words down here now. It's with an apostrophe at the end, and the word your that has a couple of letters after the apostrophe and 3 letters before. And so this works out. Now if I delete this asterisk at the end, you can see since it's not optional that these individual I's are no longer selected, and even the E at the end of your is not selected because that's just looking for the one letter, and if we put the asterisk, it's 0 or more. So it's not only optional at 0, it can select more letters, 1, 2, 3, and on. Another way to specify a quantifier is to say exactly how many of something we want. So let's bring back the digit character, and there it's selected our 8675309 digits towards the bottom, and we'll tell it we just want to select 3 digits in a row. And notice how it's also selected the 530. So if you were expecting just 867 to be selected, we definitely have to specify things or we'll get results we don't expect with regex, because now we've selected 867, that's a group of 3, and 530 is a group of 3. We can also tell it where to stop. So maybe we want it to continue to 3 or more, and this would work if we don't change anything else. This selects 4, and if we added another digit, it would select it, and another, and another. But we could also tell it to stop at 4. And now let's go ahead and delete a digit so we see a couple that aren't selected, because when I add this extra digit here, that's another group of 3. So 3 is okay, and a group of 4 is okay with this. But if I delete this, now we have selected the first group of 3 and the first group of 4, and that's why it's not selecting 900 as a group of 3, because it's already a group of 4. So the order does matter somewhat. Now previously we used a quantifier of an asterisk to say something was optional because it will select 0 or more. But we can also use a question mark to say something is optional. So we'll come back here and let's create a group, a capturing group, and let's say heart. That's the word we have in there, or just here. Let's go with here. And now it's selected those, and we'll put the letter T at the end. But let's make the here optional. And so now when we made that optional, we're also selecting other letter T's, because this will definitely select the letter T, but it will select here if it's there. And if it's not there, it's not required. And so that's why these other letter T's are selected. If we remove the optional, then it only selects heart, because now the here in heart is not optional. Something that can make regex a little confusing is the question mark is not just used for that optional thing we just explained. It is also used as a lazy selector. So let's take the letter H and then we'll say word characters and a plus, and notice how we're selecting anything including the H that has word characters after it, and that's fine. So we've selected heart, but then of course just HESE from the word these and so on. So anywhere that's starting with the H. But now this is called a greedy capture because it is selecting all the word characters after the letter H. And by default, they are greedy. However, if we put the question mark there, it makes those selectors lazy. And so now it's only selecting one word character after the letter H. And so using the question mark in this way is making a selector lazy that is normally greedy, where it matches all of those. Let's look at alternation. This is something that is very useful with regex. And we can create a capturing group, and let's put a G, and then we'll put a pipe, which is the or, if you can look at it as the word or, and then I'll put an L, and afterwards, notice it already selected all of the G's and all of the L's. Afterwards, I'll put IVE. And as songs typically rhyme, we have the word live and give, and this selects both because it can either be live or give, since we're giving an or value here for the G or the L. And so this is alternation in regex. Now that we've reviewed regex selectors quickly, let's go ahead and look at a few practical examples before we stop today. The first one, let's just put in a zip code for New York, one of many I am sure. And we know it's going to start with a number, so we can give the caret for the starting symbol, and then we want digits for sure, and there we've selected the first digit already, but now we can tell it we could just say plus, which would be a greedy selector, but that could select more digits even if that zip code had an extra digit entered, and that would be wrong. At least in the United States we have 5-digit zip codes, so let's specifically tell it 5, and from there we could also say this is where the zip code ends. Now we can make all of that a capture group by putting parentheses around it, and now you can see when I mouse over it will say group number 1 and it shows the zip code, so we have captured that. But also in the United States we can have zip codes that have a hyphen and 1, 2, 3, 4 more numbers after that. So let's change that. Now we've got the ending right there, so we need to remove that, because now we know it possibly won't end right there. So let's put a hyphen and let's make that optional. So notice without the optional tag, we're not selecting our first one anymore. So let's add optional. Now we're selecting both. Now we can have another selector group or capture group, and in there we'll say digits once again, and we'll say 4 because we know this has to be 4 to be accurate, and we'll say this is going to end the whole selection. Notice once again we've only got our bottom zip code selected, so we have to make this entire capturing group optional. And now we're selecting both the 5-digit zip and the zip code with the 5 digits, the hyphen, followed by 4 more digits. Another practical example, something would be possibly a user input from a search box or something like that. Let's put in Kansas and several spaces and then city. Programmatically in JavaScript, for sure, we have a method where we can call trim, and it will trim the white space from the beginning and the end. But what about in the middle? Let's see how to select that white space. Now, as we discussed earlier, white space is selected with a backward slash and a lowercase s. Let's see, we've got that. That also selects tabs and line breaks. What we need to do, though, is we really want a space in Kansas City. So if we were selecting this to eliminate it, we would need to specify maybe we want 2 or more instances of that white space. So we wouldn't be selecting Kansas City if it was accurate. And one more example, let's put that number in from the other classic rock song, 867-5309, and it might also be 867 period 5309, or somebody put a space, 867 space 5309, and we could imagine an area code, and then 867-5309, and then we could also imagine an international number, maybe all spaces between this time. And we need to verify or select, possibly from a form, to make sure we've got an accurate phone number. So what will we do to select that? Maybe we should work backwards towards the front or vice versa. Let's start at the back where we know we're going to end with 4 digits. So, and we always need those 4 digits. So let's create a capturing group. We'll do /D for digits. We'll specify 4 digits. And there you can see we've selected all 4. Now, in front of that, let's do a character set. And first we'll specify the hyphen because that is the most normal thing to see there. But it could be optional because it might not be a hyphen. But if it is a hyphen, it will select it. So we need to go ahead and put these other characters in our character set, possibly a period, and then possibly a space. And so now we have all of those. In front of that, once again, not optional would be, oh, and a good reason to make this optional, what if somebody didn't put in hyphens at all? So I don't think I put that version of the phone number in. So we've got 867-5309, but you can see now we're selecting the first 4. We need to get these other 3 in here. This will be very similar to what we did with the 4. We've got digits. We know it's going to be 3 digits, and we need those. They're not optional. So there we have 867-5309, the hyphenated version, the other separators as well, and it's even selecting down here. So now we really need to take this same optional group and put it in front of the 3 again. So now we have the hyphen selected here, the space selected here, and now we have an optional group of 3. So let's go ahead and put that in place and put the option. And that looks good. Now we could once again use this same optional group as we work towards our international connection. And here we will have a +1, which is the only thing we expect it to be. And let's make it optional as well. Oh, we need to escape the plus symbol. That's one of those special characters. If we didn't make this optional, none of the other numbers would be selected though. That definitely has to be there. Today we're going to look at some practical examples of using regex with JavaScript. You can see I have a basic project started here with an index.html file. I've got a main.css file inside of a CSS folder, and I have a main.js file for our JavaScript. I've already put the code into the index.html and the main.css, but I have not added any JavaScript yet. Let's take a quick look. I've got this HTML set up with a section, and this section has a form that asks for a phone number, and you can see it over here in the dev tools of Chrome, and I'm running this already with live server. You can see the local extension. Use your VS Code extensions to add live server if you don't have it, and that will allow you to run a live local server that will show your updates right away. I'll go ahead and hide the file tree again. And you can see this is a basic form. It has a label for the one text input, and this text input is expecting a phone. It's also got some hints here that will get to show up when the user starts typing to help them type in the correct information. So let's look at that real quick. We'll open up the main.js and start with a blank JavaScript file, and we're going to add an event listener. We'll say document, whoops, I need to spell right away, get element by ID, and we're looking for the phone num ID, which is assigned to that text input. Then we'll say add event listener. I need to get the text to wrap here, not listeners, but listener. And now we're going to listen for the input. User will input into the field, and that's the input event. Man, I've got typos all over today. There we go. I'll take the event. This is an arrow function. Now we're ready to type in our event listener. And the first thing we're going to do inside this event is put in our regex pattern. So I'll define a variable named regex. You know, I'm just going to make this the whole screen for now so we can see a little bit better. Our regex pattern. Now this does not go inside quotes like a string would. We just put it in between the slashes. And we're looking for a phone number. So we want it to start out with, and now we're not going to look for an international phone number in this example, but we could. We're going to start out with possibly a parentheses. And I say possibly because we won't make it required. So with the question mark, we make that optional. And now we'll have our first grouping, and that looks for digits, and we're looking for 3 digits like an area code. And now we'll also escape and put a possible closing parentheses. So we may just start with 3 digits, or we may start with 3 digits inside of parentheses. Now let's put a character set between brackets, and this will hold possibly a, or this could be possibly a dash, a period, or a space. And these special characters like the dash and the period do not need escaped inside the character set. And again, we'll make those optional. So it could be 555 dash and then the next set of numbers. And that's what we need to put here. So we'll put, this is not looking for parentheses, but this is starting another group that we could be selecting. So this will be digits again, and we once again expect 3. And now we'll once again have an optional dash, period, or space, because people could enter their phone number with no dashes, periods, or spaces. It could just all be numbers as well. So we're going to expect any of that. And then we'll end with 4 digits. And now after the 4th digit, and this is once again a capture group, we'll put the ending character because that's how it needs to end. We'll put the last slash. That indicates now that this is a regex, and we need to put the global flag. And there we have defined our regex that we will search our input string for. Now let's select the input, and this will need to be get element by ID, and we're getting phone num, just like we did to add the event listener. And then we'll have format. And here we're going to use a query selector because we're going to select by class. This is the phone format class, and that is the paragraph that will help assist how to type in the information for this input for the user. And now let's define just phone, and we'll call this input dot value. And so that, not node value, just value. And that is the text that the user inputs into the phone num. So we declared input here, and now we have used it there. One more variable, I'll call it found, and this is where we will apply the regex. And we'll use the test method. Whoa, I need to type better. regex.test. And then we pass in the phone variable. And remember, that is the input value. Now we can have an if statement. Let's say if it is not found, and regex.test will return true or false. So the exclamation mark and found will mean false. Likewise, without the exclamation mark in front of it, it would be true. We'll say if found is false and phone.length is true. So if the length of the input is not 0, because 0 would evaluate to false. Now we'll choose the input once again. Remember, that's the phone number input. And then we'll get the class list, and we'll add, and we have an invalid class in the CSS. And then we'll get the format, and we'll go class list again. And remember, this is the paragraph that assists the user in knowing what to type, and we'll put block. So that paragraph shows up. So this means if it does not match the regex that we're testing for, and there is data in the input field, we're going to apply the invalid class, and we're going to give the user some hints as to what they need to type. Now let's put else, and this means if there, 1, there could be no input in the input field, or 2, we've matched the regex pattern and everything is valid. So let's put input.classList.remove invalid, and then we'll do the same for format.classList.remove block. So we once again hide those hints. And just so you know, let's look at these classes real quick. In the CSS, we have got block, which is just display block, and invalid will just turn the text red. That's what we're going for. And once again, we're working with this section that has the form, and here's the input, phone num, and now here are the tips that the user will see if they have invalid input at the time. So let's look at this in Chrome. And now we've got enter the phone number. And I'll go 555. Now see, we have red text because it does not match the regex pattern at this point. And the tips for the user showed up. If I delete the text, they hide, and the cursor is not red, so this text is not red. But let's go ahead and enter in a number, 555-555-1234. It matches our regex pattern, and the tips for the user have now gone away. Likewise, we could do 555-123 space 1234, and that works. Or we could put periods between everything, and that matches. Spaces would also work. So our pattern is working, and our feedback for the user is also working. Now let's look at adding some JavaScript for when this is submitted. They say the user has entered in their information and it matches the regex pattern, and they attempt to submit it. So let's go ahead and add a listener to the form as well. So we'll say document.getElementById, phone form is the ID it has. We'll go add event listener. Now we're listening for the submit event, especially when a form just has one input, like a text input, and the user presses enter, it automatically fires the submit event. We don't need to add anything else. And likewise, if there was a submit button right next to that text input, just clicking the button would also fire the submit event. So you can listen for one event for both of those actions. We don't have a button today, just passing that information along. Submit event, and here's the listener. First thing we want to do is event.prevent default, because a form will reload the page. So we would briefly see information and then the page would reload. And that's the default behavior of a form. So we need to prevent that default. And then we'll define an input variable again. And this will be the same as we had up here. So let's just copy that down and add that to this function. Now let's define a new regex. And we'll define this regex. We have to start with a slash. Now let's have a character set, and we'll put in parentheses, put in the hyphen or dash, whichever you want to call it, period, and a space. Any of those could have been entered into an accepted phone number that met our previous pattern. And then we'll once again put the global flag. And now let's define a variable called saved phone num. And we'll set that equal to the input.value. And now I'm going to call a different method than test. I'm going to call replace all to use with this regex. And we'll pass in the regex, and then I'm going to pass in well, basically nothing, an empty string. So any of those will be replaced with an empty string. After passing in the empty string, let's just log this saved phone number to the console so we can see what happens. The plan is to remove any of these extra characters, because all we would want to store possibly in our database or send to an API or whatever, after we get the phone number out of the form, we just want to send in the numbers once we have validated them. So we'll save that, go back to Chrome, and now let's type in a number once again. Let's say 123-123 space 1234. Looks good. I'll press enter. And now you can see we've removed the dash, we've removed the space, and we just get the numbers. Let's do it again, and we'll go 555-123-1234. And we just get the number. So our regex is working. It's eliminating those characters we don't want, and then it's just passing along the numbers for us to work with. One more practical example. I have a second form in a second section of this index.html file, and you can see this form is almost identical. It has a text entry, but we just want the user to enter some text. This could be a field, possibly say a weather app, where the user is entering in a city name to look up the weather for a specific city, or it could be just a message field or a search field or something like that. This is just a text entry. So we're going to apply a regex to it that makes sense for most things a user would enter. And now we'll just come back here to the main.js. I want to go ahead and scroll to the right part of the page. So we'll just scroll on up, and here is our second form. It says, please enter some text. Now we're not trying to validate this in any way. We just want the user to enter some text. And you can see it works just fine. But the function we want to add, we'll go ahead and add an event listener, and then we'll put a function inside that listener. So let's say document.getElementById, and this is the text form. We're going to listen for submit event. Once again, and there's the event. It's an arrow function. I'm going to scroll up just a little bit. There we go. And now the first thing we want to do with the submit event in a form, once again, is the event.prevent default. We don't want the page to reload on us. And now we're going to define our input once again, but this is a different input. It's document.getElementById, and this is our text entry ID. Now let's define a regex. And I'll tell you what we're looking for. We are looking for occurrences of more than one space. And so I'm just going to put a space. Now with regex, you could put a backslash and a lowercase s, and that indicates spaces. It also indicates tabs, and it indicates line breaks. We just want the spaces, so I'm just going to type a space. And then we're looking for 2, and then I put a comma because 2 or more. If we were just looking for 2 to 4, I could put 4 here, but we want 2 on up to infinity probably, however many there are. We just want more, so 2 or more. And then we'll put the global flag. And this will find any occurrence of 2 spaces or more that are in a row within the string that the user enters. Now I'll define new text. And this new text is the input value. And then I'm going to call replace all. Pass in the regex once again. And I'm going to put in 1 space. We don't need 2 spaces. We'll just put in 1. And then on top of that, I'm going to chain the trim method, and this trims the white space from the beginning and the end, because if the user put 2 or 3 spaces at the beginning, our current regex would just replace those 2 or 3 with 1 white space, and we would still have 1 space at the beginning or possibly the end of our string. So I want to trim any white space from the beginning or the end after we've applied the regex. We can do that all in the same line. Now let's go ahead and log this new text. And we'll stop there for now. And once again, this is when the user submits. I put next text there. It needs to be new text. This is when the user submits the form. Let's go back to Chrome. And I'm going to type, I'm in the wrong spot. It scrolled back because I saved the file. So there we go. I'm going to type Kansas. Matter of fact, let's go ahead, space, 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 and then type Kansas City. That is a city with 2 words and some space in between. Now I add a few extra spaces and press enter. And you can see we just get Kansas City with the 1 space between the 2 words. And that cleans that text right up. We could do New York. And we just get New York like we expect. Now, I mentioned possibly sending a city name to a weather API, which is just one example. When you do that, you would build a URL to submit because they would have an endpoint that you would need to send this data to. So you'd probably be building a URL inside of your code. Let's look at what we might do there and look at the difference. I'm going to define a variable called encoded input text. And I'm going to set that equal to encode URI and then put the input value. This is a method you could call in JavaScript, and it encodes your URL that you're making, that you're sending along. So you don't send a space. You know, URLs, web addresses don't have spaces in them, so you need to encode it first. Now let's also look at encoded, and I'll call this clean text. Whoa, got a space I didn't need. Clean text. And I'll call encode URI again, and now I'll pass in the new text we created. Now let's log both of these and look at the difference. So encoded input text, and then we'll also log, whoa, encoded clean text. There it is. I'll save that, and we'll still be able to see what we were looking before, so we'll also look at the new text. But let's look at what, if we didn't clean the text, basically what would be added to a URL. So I'll put, once again, like 3 or 4 spaces, Kansas, a lot more space, and some more space at the end. I'll press enter. You can see this is what we had to begin with. It's cleaned up the text, Kansas City. But this is the text if it wasn't clean. Each one of these %20s represents a space. So we had about 5 spaces before the word Kansas, many more spaces before the word city, and many after. So if you don't clean up your text, all of this would be inserted into that URL, and the API might not like that. However, if you clean up the text, you're just going to submit Kansas, 1 space, and that's represented with the %20, and city. And you've probably seen that before, whether you're shopping on Amazon or some other site. They pass along parameters at times in the URL, but they have to encode those because a space may be in there, or there may be other characters that get encoded. And this encode URI will do that for you. But go ahead and clean up the text first. And that is another practical application of applying a regex. Hi, I'm Dave, and I hope you enjoyed this tutorial. Remember to keep striving for daily progress instead of perfection. Subscribe to my channel and ring the bell to be alerted when I post new tutorials. I'll see you next time.